Hi, welcome back. Let's try the example number 2 now. A picture of 10 newtons hangs freely by a string XYZ as shown. Calculate the tension in the string. So let's try. Remember, the first step is to look at all the forces, and all the forces here are already clearly marked out for you. Just that, let me maybe highlight it a little bit. Tension here, and we have the weight 10 newtons over here. The first check that we need to do is that does this lines of action pass through a common point, which is the checkpoint over here. If you look at the lines of action, what do I mean? Lines of action is that when you take dotted lines along the forces, you make a dotted line along the forces, you'll see that these dotted lines pass through the point 1. Right? This is the first check that we need to do to convince ourselves that it is possible for these forces to be in equilibrium. Once we have that, we can do step 2, which is to rearrange the vectors into a closed triangle. So next, T, right? The question already tells you that the picture is in equilibrium. So the vector diagram must form a closed triangle. This is 10 newtons. If you look at the angle here, let's say 60 degrees, we know that this angle here is 60 degrees, which means that this angle here is 30 degrees. Okay? The next thing we notice is that the two T's must be symmetric to each other because of the angles, which means half of the height of this triangle is 5, right? This value here is 5. So if you then look at this triangle, we can use cosine 30 degrees, right? What is it? It is actually 5 newtons over T. If we then want to find the value of T, T is here, 5 over cosine 30 degrees. Well, the rest is just math, so I shall not bore you. Answer is actually 5.77 meters. Done. Right, it's a very simple example to illustrate to you how to find values of. Next, this question is a little bit more tough, right? Need to be able to see and find the angle, because in the previous questions the angles have been given to you. In this question, the angles are not. So let's see. A smooth sphere of weight 10 newtons is connected to a string on one end. The other end of the string is connected to point C on a smooth vertical wall. Interestingly, the alphabets have disappeared. Oh, wait, they're back. Right? Connected to point C over here. The sphere is in contact with the wall at point A. If the length of the string here is equal to the radius of the sphere, calculate the tension in this string, part A, part B, the normal reaction force of the wall of the sphere. Right. So first step is to draw the forces on the object. So tension acts on this point here and it points outwards. Right? If we dot out the lines of action, it goes through O. At A, there's a normal contact force pointing perpendicular to the wall out onto the sphere. So it points out this way. We can call this value M. Right? So the red one is called tension T. The blue one is normal reaction force M. Does these three forces pass through a common point? Answer is yes. Right? So let's rearrange now the forces and see what we get. N Remember, we need to form a closed triangle, T, and next there's W. And here there's angle theta. What is this angle theta? Well, let's look at the physical dimensions of this thing. Let's use the color green. There's a radius R here. This is also R, right? The length of the string is also R. Hence, essentially, you have a triangle here, 90 degree, 2R, and R over here, the angle theta. So with this, you can actually do using cosine to find the angle theta first. So cosine theta is R over 2R, which is hence half. Using this, you can find the angle of theta to be 60 degrees. Right, that's the first step, the first difficulty. Once we have this angle, we can fill this in over here. What are we asked to do now? We are asked to find the value of tension in the string. So remember, the weight here is 10. To find tension, well, that's simple, right? Because sine theta, or sine 60 degrees, is just 10, the weight value, over tension. If we rearrange, T is 10 over sine 60 degrees. We get 11.5. Right, that's your answer for part A. For part B, we have to find the normal reaction end of the wall on the sphere. Once again, we are just trying to find the value of n here. So what can we do? Right, well, let's use tangent. Right, tangent of 60 degrees is W over n. W is the value of 10, so n must then be W, which is 10, over tangent 60. If you use your calculator and key in the value, well, that's not difficult. The value is 5.77 newtons. Okay, that's your answer for part